Guys, good evening, warm good evening to everyone. Yes, as you know, this is our physics class, and I'm Mr. Arun. Having almost 9+ years of experience. You know, have dealt continuously for NEET and CET, constantly for it, and have achieved number of rankings through my students. And yes, this is my YouTube Unacademy's YouTube channel where I'm getting exposure, a very good exposure. And yes, of course, let's begin the classes. The first thing which I want to tell you is, as usual, you know, I would like to give you the details regarding the prescriptions, the subscription of the Unacademy. That is, the best plans for Karnataka KCET is already live. That is, for 12 months, it would be 12,375. For 6 months, it would be 10,125. For 1 month, it would be only 2,250. The comprehensive batch is live for the complete syllabus preparation. Right. So, what does this includes? Obviously, the premium content at the affordable prices, the structured live classes plus doubt clearing sessions, quizzes at the regular interval of time for self-analysis, batches for complete preparation, and test series for DBP, full-length mock test, etc. with analysis, single subscription for unlimited access. Right. Now, so that batch, the comprehensive batch, as I said, Karnataka KCET 2021 comprehensive batch is live on Unacademy Plus, right? So, where the complete syllabus will be covered, tips and tricks, by the top educators, topic-wise practice questions, full-length mock tests, right? So the plan would be for 1 month, it would be only 2,250 till the end of September. And you can use my referral code Arun K Live for any sort of discounts on the price which we have quoted. Right? Now, so as you know, this is the very first class of electrostatics, that is electric charges and fields, where you're going to learn about what do you mean by a charge and what are the equations which is going to come with respect to charges and fields. Then I'm going to begin with the questions which I'm supposed to discuss. Hardly for 5 to 10 minutes I'll be discussing about theory. Then I'll be going ahead with the questions. Right? Now, first, before I start, first let us see what is the definition of charge. Right? The moment I say charge, what do you mean by it? Right? The charge is a property associated with the matter due to which it produces an experience of electrical and the magnetic effects. Let me tell you very clearly. Say you have an object of mass, right? If you place it in the air, what exactly this mass will do? Whether it is going to stand in the air itself? No. What is this? Due to the gravitational pull, it is going to come and sit on the ground. Due to gravitational pull, it is going to come and sit on the ground. Right? Why? Because it is getting, gravitational force is getting applied on the given part, is getting applied on the given object of mass, right? Now, because of which the particle will get, it is going to experience a gravitational force. Because of which it is going to come and sit on the Earth's surface, right? Now, why do a gravitational force will act on a given object? By Newton's law, we can explain it very easily. F is equal to G m1 m2 divided by r square. Right? The gravitational force which gets applied on any object is directly proportional to the product of its masses and inversely proportional to the square of its distance. Right? Similarly, for gravitational force, as the mass is a basic requirement, right? If an object is having the mass, then only it's going to experience a gravitational force, right? So for the gravitational pull, as the mass is a basic requirement, for electrical force, a physical quantity called charge is a right? As you know, we know from our lower class itself, like charges will repel each other, unlike charges attract each other, right? We know everything, right? But how? Why? Yes. Let us try to understand that one. See, I'm keeping it very straight and very simple, not lagging or not trying to lag it anything. Right? Where do this concept of charge and mass arises? Yes. Whenever you have been asked with what do you mean by a charge? Yes, they will say it is a it's a property of any matter due to which a matter will experience a electrostatic force of attraction or repulsion. Right? Anyone will define this. But why does charge exist? Why? You just start thinking, you start sticking to the basics, you will only understand why exactly is that. Right? Now, say to understand that, what is the basic unit of every matter? An atom. Right? Fine. What does this atom consist of? Yes. An atom consists of protons, neutrons, and electrons. Right? This atom consists of protons, neutrons, and electrons. Right? Now, what do you mean by this proton? Right? The proton is a positively charged particle. Electron is a negatively charged particle. Meanwhile, neutron is a neutral particle. Neutron is a neutral particle. Right? An atom consists of proton, neutron, and an electron. Right? Where proton is a positive charged particle, neutron is a neutral particle, where electron is a negatively charged particle. Right? Now, this charged particle has two basic things in it. One is the mass of it, and other one is the charge of it. Right? This elementary particles consist of two things. One is mass and the other one is charge. Right? Because of mass, see, if I consider a ball, a tennis ball, right? So how many atoms will be there? There will be crores and crores of atoms. Right? Those crores and crores of atoms, if they have only one proton, how many protons you have? Crores of protons. If that one atom consists of one electron, means how many electrons you are having? You are having crores and crores together of electrons. Right? So we say that a matter is made up of this molecules. Right? And these molecules is nothing but an atoms. Right? It's made up of atoms. What is these atoms are made up of? Yes, elementary particles like protons, neutrons, and electrons. Right? And this protons, neutrons, and electrons, yes, Nasima, good fun, Ahmed, hi, thank you for joining the class. If you have any doubts, you can ask. Fine. Okay. Yes. So these elementary particles have this basic property of mass and charge. Because of mass, the object, any object is going to experience a gravitational force, right? Because of the charge, any object are going to experience the electrostatic force of attraction or repulsion. Electrostatic force of attraction or repulsion, right? Because of charge, they are going to experience electrostatic force of attraction or repulsion. Because of mass, they are going to experience a gravitational force. Right? Keep this thing in mind for a clear understanding of the concepts. Right? What do you mean by charge? Yes, the charge is a basic or an intrinsic property of any matter because of which a matter is going to experience an electrostatic force of attraction or repulsion. Keep that simple. Right? Okay. So we came to know what is the value. What do you mean by a charge? Right? Now, what are the properties of charge? Let us see. What are the properties of charge? The first thing, the charge is additive in nature. The charge is additive in nature. Try to understand this. What do you mean by that? The charge is additive in nature. Looks very complicated, but it is simple. It looks very complicated, but it is simple. What do you mean by that? Let's have a look at it. Say, I have 4 different balls, right? 1, 2, 3, and this is 5. All the 4 has been kept. all the four can be if it has been considered in a system, in a box, let us say. If I ask you, what do you mean by, if I ask you, say, this is of charge 1 coulomb, this is of charge 3 coulomb, this is of charge minus 2 coulomb, this is of charge 1 coulomb, right? Now, sir, it can be applied for JEE mains. Yes, of course, it is a basic. You can apply it for JEE mains as well as for JEE advanced, right? Now, so 1 coulomb, 3 coulomb, 1 coulomb, and minus 2 coulombs, right? 1 coulomb, 3 coulomb, 1 coulomb, and minus 2 coulombs. What is the charge of the system? Additive in nature. 1 plus 3 minus 2 plus 1. How much is this? 1 plus 1 is 2. 2 minus 2 is 0. So the charge of the system is 3 coulombs, right? The charge is additive in nature. It can be directly added. You are no need to bother about what is the direction of the charge, right? It is a scalar quantity. The second property is the charge is a scalar quantity, and the first property is the charge can be added directly, right? Say, sir, I have n particles, right? I have n particles, each of charge 1 coulomb. So each of charge 2 coulomb. Then what is the total charge of the total charge of the particles? It is 2 into n. Right? Simple. Adding directly. I said, say I have n number of particles, each are having 2 coulombs, then what is the total charge of the system? It becomes 2 into n. Sir, I have minus 2, yes, minus 2 into n. Simple. Right? If it is plus, it is plus. If it is minus, it is minus. Fine? Now, let us move to the next one. Yes, the second one, a charge is quantized in nature. The charge is quantized in nature. Let us try to understand what you mean by this. We say Q is always equal to plus or minus n into Q is always equal to plus or minus n into E. I don't take too much of time, hardly another 5 minutes I take, so that we can quickly move to the problems. Right? So Q is equal to plus or minus n into E, where n is a integer. So n is a integer. And E, it is the charge of a charge carrier, right? Charge of a charge carrier. Charge of a charge carrier, right? N is an integer, I said. What do you mean by this, sir? Let us try to understand. Integer means what? N must be equal to either plus 1 or minus 1, plus 2 or minus 2, plus 3 or minus 3. That is so on. From that, say, I have 2 conductors here, conductor 1 and conductor 2. Right? I have bought the conductor 1 in contact with each other. Right? I have bought the conductor 1 in contact with conductor 2. Right? Have you ever imagined that, sir, half electron has got transferred? Is it possible? Absolutely. Right? Half electron cannot get transferred. Right? Like, it's like cutting our leg and transferring it. No, it is not possible. Right? Cutting the leg of the electron, transferring it. No, it is not possible. If an electron gets transferred from one conductor to another conductor, means it fully gets, moves from one conductor to another conductor. Right? Always keep this in mind. It is the meaning of it. Right? So the charge is always an integral multiple of charge of a charge carrier. It's always an integral multiple. Other n is an integer. All remember this. This equation. We are going to use it so many times. Q is equal to plus or minus n into E, where n is called as an integer. Right? N is called as integer. Right? So let me move to the next one. Yes, charge is conserved in nature. Obviously, it is conserved. Right? It cannot be created. Right? Charge cannot be created. Right? Next, obviously, as I said, electric charge is a scalar quantity. Electric charge is a scalar quantity. Yes, it does not have any sort of direction. It is a scalar quantity. And obviously, the fifth one you can quote by yourself. What is that one? Like charges repel each other, unlike charges attract. Right? So the famous one, which you already know, so which I don't want to discuss. Right? Now, similar to your Newton's law of gravitation, force between the two charges, has been formulated by Coulomb. The scientist's name is Coulomb. We call it as Coulomb's law. It is a very famous law. Coulomb's law of electrostatics. A very famous law, Coulomb's law of electrostatics. That is, what does he says? See, try to recall, Newton's law of gravitation. Newton's law of gravitation is Newton's gravitational force is always directly proportional to product of the masses, and it is inversely proportional to square of the distance. Right? Gravitational force. Who is responsible for gravitational force? It is masses. Who is responsible for Coulomb force, or what you call the electrostatic force? It is charges. Q1 into Q2. Right? F is inversely proportional to square of the distance. Right? So I can write F is equal to, removing both the proportionality constants, so K is equal to Q1 into Q2 divided by S. Right? Where K is called as electrostatic. Force constant. K is called as electrostatic force constant. Right? The K is called as electrostatic force constant, and Q1 and Q2 are the charges. Right? Now, see, number of times, I think in one or two situations, you have been asked what is the unit and dimensions of K. There are two things to define. Since you already know this, I will try to go a little bit faster. Right? As you know, this K will be replaced by F is equal to 1 divided by 4 pi epsilon naught to Q1 into Q2 divided by R. Right? Now, this K has been replaced by 1 divided by 4 pi epsilon naught. Right? Now, number of times, most of the students will get confused with what? They will ask you, what is the dimensions or what is the unit of electrostatic force constant? Number of times. But they will write the unit of epsilon naught, that is absolute permittivity. Number of times this has happened. Right? You will get confused with unit of K and unit of epsilon naught. Unit of K and unit of epsilon naught both are not same. Right? K is called as electrostatic force constant. Epsilon is called as permittivity. Epsilon naught is called as absolute permittivity. Epsilon R is called as relative permittivity. Right? Now, let me define you how exactly we define epsilon. Epsilon is defined as epsilon naught into epsilon R. Epsilon is defined as epsilon naught into epsilon R. What do you mean by epsilon naught? It is absolute permittivity. Right? Permittivity of the air or vacuum. Right? Epsilon R is relative permittivity. Epsilon R is equal to epsilon divided by epsilon naught. Right? It's a comparison. Right? It is the permittivity of one space with respect to air. Right? So, epsilon has got the same unit, has the same dimensional formula of epsilon naught. Dimensional formula of epsilon and epsilon naught both are same. Remember, units and dimensions of epsilon and epsilon naught both are same. What is the units and dimensions of epsilon R? It does not have any units and dimensions. Epsilon R does not have any sort of units and dimensions. Epsilon R, not epsilon naught. Remember, epsilon naught and epsilon both have units and dimensions, but epsilon R, that is relative permittivity or dielectric constant, will never have units and dimensions. Remember, right? Now, ಹಾಗಾದ್ರೆ what is the unit of K, what is the unit of epsilon? Easy to remember, very easy to remember. Let us see what is how is that. Let us see how is that. See, we write F is equal to K into Q1 into Q2 divided by R square, right? Now, to get the unit of K, I'll arrange for K now, F into R square divided by R1, sorry, Q1 into Q2. What is the unit for force? It is Newton. What is the unit for distance? It is meter. R square is there, so it is meter square divided by charge is Q1, Coulomb. Q2 is also Coulomb, so it is Coulomb square. So it is Newton meter square per Coulomb square is the unit of K. Newton meter square per Coulomb square is the unit of K, that is electrostatic force constant, right? Similarly, if I want, what is the unit of epsilon naught? What is the unit of epsilon naught? What I'll do, in the place of K, let me write as 1 by 4 pi epsilon naught, right? Now, epsilon naught unit I want, so epsilon naught is equal to Q1 Q2 divided by F into R square, right? So I can write this one as Coulomb into Coulomb is Coulomb square divided by Newton's meter square, or Coulomb square per Newton per meter square is the unit of epsilon. Andre unit of epsilon is always the inverse of K, or reverse. Unit of K is a reverse, is the inverse of epsilon naught, right? What is the unit for epsilon R? No, it does not have any unit, because both will get cancelled. Unit of epsilon and epsilon naught will get cancelled. So epsilon R, or dielectric constant, will never have unit. Keep that in mind. Now, in a similar way, we can write what is the dimensional formula, right? How to write the dimensional formula now, right? See, what is the dimension formula for F? 1 in L minus 2 in T multiplied by 2 in L divided by, A into T is the dimensional formula of, Coulomb. So you have 2 times, so it is A square T square is the dimensional formula of Q1 and Q2. That's Q1 into Q2, right? If you simplify this, see, L power 1, L power 2, it becomes L power 3. So M power 1 will remain as it is. 3 in L minus 4 in T, because T comes to numerator, becomes T power minus 2. A power minus 2. This is the dimensional formula for K, that is electrostatic force constant. Similarly, for epsilon naught, what is the unit? Inverse of it. As unit is inverse, dimensional formula is also inverse, that is minus 1 in M minus 3 in L plus 4 in T and plus 2 in A. That is the dimensional formula for epsilon naught, that is absolute permittivity as well as permittivity, right? So let us move to the next one now. Yes. So we have defined Coulomb's law. Always remember, Coulomb's law is applicable only for point charges. Only for point charges, right? And as you know, the value of K, that is electrostatic force constant, is 9 in 10 power 9. Epsilon naught value is 8.8 in 10 power minus 12, right? Now, what is the first question? 2 point charges, 2 coulombs and plus 6 coulombs. 2 point charges, 2 coulombs and plus 6 coulombs repel each other with a force of 12 newtons. They repel each other with a force of 12 newtons, right? Repel each other with a force of 12 newtons. What will be the if a charge of minus 2 coulombs, is given to each of these charges, what will be the force now? Right? Try to understand that question. A simple question to begin with, right? So I have 2 point charges now, Q1 and Q2, right? Yes. I have 2 point charges now. That is 2 coulombs and 6 coulombs, right? I have 2 point charges, 2 coulombs and 6 coulombs, right? Now it is 2 coulombs, I have 2 point charges, 2 coulombs and 6 coulombs. This is plus 2, this is plus 6, right? Both has been separated by distance of r, right? When both has been separated by distance of r, they repel each other with a force of 12 newtons, because like charges they are going to repel each other, so with a force of 12 newtons. Right? Now, if what is given there? If a charge of minus 2 coulomb is given to each of these charges, if a charge of minus 2 coulomb is given, that is, if I add minus 2 to this and if I add minus 2 to this, what is the new value of charge? New value of charge will be 2 plus 2, so 2 minus 2, it is 0, right? And this one is 4. So Q2 value is 0, Q1 value is 4, right? Now I am supposed to find, the distance is say r, you are supposed to find what is the value of force between them. F is equal to 1 divided by 4 pi epsilon naught into Q1 Q2 divided by r square, right? So F is equal to K into Q1 value is 4, Q2 value is 0 divided by r square. 0 into everything is 0, 0 divided by anything is 0. So force between them is also equal to what? A very simple question to begin with, right? So step by step you are supposed to solve the problem, fine? Now what is the answer? Answer must be 0, right? So let me move to the next one. Yes. Four charges arranged at the corners of the square. 4 charges arranged at the corners of the square A, B, C, D. 4 charges arranged at the corners of the square A, B, C, D, as shown in the figure, as shown in the adjoining figure. The force on the charge kept at the center O is, the force on the charge kept at the center O is, right? Option A, it is 0. Option B, along the diagonal AC. Option C, it is along the diagonal BD. Option D, perpendicular to the side AB, right? Perpendicular to the side AB. Let us see what is the shortcut we can adopt for this kind of problem. I am going to give you the shortcut now. What is that? Let us try to understand. Yes. This shortcut is applicable for all geometric, for all sort of geometric shapes. It may be a square, it may be a triangle, it may be a rectangle, it may be a polygon, it may be a hexagon, anything. It is applicable for all geometric shapes. Fine. Now, the second one is, if you want to apply this shortcut, the charges must be a like charges. The charges must be a like charges, or in specific it has to be a identical charges. The charges must be identical charges. Right? Always remember this. The third point is apart from this rule. Fine. What is that? Always remember the electrostatic force. The electrostatic force always acts along the line joining the two charges. Along the line joining the two charges. This is a universal rule. What is that? Direction of electrostatic force is a universal rule. It is, right? What is that? Electrostatic force. What is the direction of electrostatic force always? Electrostatic force always acts along the line joining, along the line joining between the two charges. It may be towards the another charge, it may be in a direction opposite from the another charge, right? It is the next thing, right? It is the next thing, but always consider it always acts along the line joining between the two charges, right? Now, how, sir? Let us see. Say I have a square now. I have a square, and I have the charges at the vertices of a square. So this is A, this is B, this is C, this is D. Right? Before I go to the square, let me show you in two simple things. This is Q1, this is Q2. Am I correct? Q1 and Q2 along the line joining the two charges. So let me draw a line. Right? Now Q1 will repel Q2. Correct? Meanwhile, Q2 will also repel Q1. Am I correct? Right? Now, what is the direction? Q1 will repelling Q2 along the line joining. That is, repelling it has to push away. Right? Repelling means pushing it away. Attracting means pulling it towards. Right? So Q1 will push the Q2 outward, in the outward direction. Adhe riti, Q2 will also push the Q1 in the outward direction. This is F2, force applied by Q2. This is F1, force applied by Q1. Right? The direction in which the force acts, right? It is important. For the next upcoming problems, it is important. Always remember, the electrostatic force always acts in the line joining, along the line joining between the two charges. Right? Now, if you want to find, as I said, in any geometrical shapes, if you have identical charges at the vertices of its corner or at the corners of a given geometric shape, what is the shortcut is? The F net value at the center is always equal to 0 if you have identical charges. Remember, if you have identical charges, identical, I am continuously repeating it. What kind of charges you must have? You must have identical charges. If you have identical charges, it may be any shape. It can be a triangle. It may be a square. It can be a rectangle. It may be any shape. The net force at the center, if you have the identical charges, the net force at the center is always equal to 0. Remember this. No need to waste the time on such type of question. No need to waste the time. Right? If you have geometrical shapes, observe identical charges. If it has been asked to find what is the force at the center, right? Immediately it is 0. Keep the thing in mind. Right? What are the two rules? What is the only one rule? The charges must be identical. That's it. If one is plus, all the three must be plus. If one is plus, all the remaining must be plus. If one is negative, all the remaining must be negative. Right? Keep the thing in mind. Right? Next, let us apply this rule for this question now. Right? Note. What is the given question? You have Q, you have 2Q, you have Q, and you have minus 2Q. Do I have identical charge? No, I don't have identical charge. Right? So I cannot apply the rule now. Right? Right? Okay, yes. I have a square. Say the charges are Q. This is plus 2Q. This is plus Q. And here I have minus 2. Right? That was this time. Right? If you were having identical Q's, the charges at the center would have been 0. But in this case it cannot be 0. Right? Now, so you are supposed to find the force on the charge kept at off. Right? So let me consider I have kept a charge Q0 at off. Q0. Now, I don't need to find magnitude in this one. I want to find only direction. Always keep that in your mind, because in this one they have been asked what is the direction, that's it, right? So force due to A, if I call this is A, this is B, this is C, this is D, right? Force due to A would be in what direction? Would be acting towards C. Am I correct? Force due to A would be acting towards C. What is the value? F is equal to K into Q naught divided by R square, because distance from the center to any of its diagonal is always zero, always same, right? Similarly, the force due to Q, another term, ili Q naught, ili plus Q, both will repel, acts along the lines on it, so it acts in the opposite time. So what is the value of Fc? This is Fa, this is Fc, K into Q naught divided by R square. Are they equal in magnitude? Yes. Are they opposite in direction? Yes. Both will cancel out. Hagadra, the net force due to A and C is equal to what? 0. Keep the thing clear. Next. Now, due to B and C, let us find. Due to B, no? What is the direction of force acting? It will be acting towards B. Right? Similarly, force due to D will also be acting towards D itself. Why? Because it is a negative charge and it is a positive charge, right? Positive and positive will get repelled, positive and negative will get attracted. Hagadre, this is O, this is D. The net force will be is in what direction? It is the direction of OD, right? Hagadre, the net force is acting along the diagonal OD, andre along the diagonal BD. That is option C is your answer, right? What is the shortcut we have learned in this question? If we have identical charges, then the net force at the center of any sort of geometric figures is equal to what? 0. Always remember this, right? No need to waste your time in your examinations, because every second is important in your examination, so no need to waste the time, right? Next. Identify the wrong statements, right? Identify the wrong statements. Always they will not give you right statements. They will try to give you wrong statements also, right? Identify the wrong statements in the following. Coulomb's law correctly describes the electrostatic force that option A, electron of the atom to its nucleus. Yes. What force binds the electrons to its atom? So electrons to its nucleus. Yes. Positive protons will always try to attract negative electrons. That is nothing but a centripetal force. That centripetal force is acted due to what? Electrostatic force. So option A is correct. So electrostatic force binds the electrons at nucleus, binds the electrons in the atom or to the nucleus, right? Next, second one, binds the protons and neutrons inside the nucleus. This is something strange, I think. This is something strange. Protons and neutrons, why do they bound to be inside the nucleus? Why? Because of nuclear force. Because of strong nuclear force. It is not due to Coulomb's law, or it is not due to Coulomb force, right? It is due to strong nuclear force. They have been binded inside, right? Option B is the wrong statement we have to make. Let us see option C and option D whether they are correct or not. Binds the atom together to form molecules. Obviously. See, if you take the example of H plus and Cl minus, there must be an electrostatic force. If you take the example of H2O, there must be a Coulomb force, right? So obviously binds the atom together to form the molecules. We have to fully agree with that. Next, D, binds the atoms and molecules together to form solid. Absolutely right? Hagadre, only B is the wrong statement, right? I think I can move to the next one. Yes. Three charges are placed at the vertices of equilateral triangle. Three charges are placed at the vertices of equilateral triangle of side A. Right? Three charges are placed at the vertices of equilateral triangle of side A as shown in the following figure. As shown in the following figure. The force experienced by a charge. The force experienced by a charge. The force experienced by a charge placed at the vertex A. Placed at the vertex A in the direction normal to BC. You have to be a little bit careful while reading the question, because we have to be very cautious. Every word in the question will try to give the hint in your competitive examination. Right? Every word. Right? So what is that? Let us see. 3 charges are placed at the vertices of an equilateral triangle of side A. Fine. 3 charges are there, are placed at the vertices of a triangle as shown in the figure. One is plus Q, other one is minus Q, and other one is minus Q. Right? Let me write the diagram in our board now. So I have 3 charges. I have 3 charges. It is plus Q, minus Q, and plus Q. Right? Plus Q, minus Q, and plus Q. Right? Now, it has been placed in the equilateral triangle of side A, obviously. You are supposed to find the force experienced by the charge placed at the vertex A. This is your vertex. Right? What is the force experienced by this A? You are supposed to find. Right? But what is the condition? Let us see. It has to be normal to BC. The force experienced at the vertex A in a direction normal to BC. Another perpendicular to BC. This is the point where you will not highlight, or you will not look at, or you normally miss. This is where you normally miss it. Fine? Read every word cautiously so that you can solve it clearly. Fine? Now, so I have to find what is that force. What is that force which acts perpendicular to BC? Right? Which acts perpendicular to BC. Right? Fine. Let us see. This is your A, this is your B, this is your C. What is the direction of FA? What is the direction of force due to B acting at A? Force due to B will be acting towards B. Am I correct? FB is acting towards B. Why so? I got a confusion. Why it is so? Yes, positive, negative. We will try to practice. Right? Now, positive and positive will try to repel. So FC will act in this direction. This is the FC. What is the angle between FC and FB? It is 120 degrees. Why? How much is this? It is 180. Am I correct? How much is this? It is 180. How much is this? It is 60. Correct? So the angle must be 120 degrees. Am I correct? No. You are supposed to find what is the force which is normal to BC. Right? Where exactly is BC here? BC is here. The force which is normal to BC. Right? Now, do you have any force which is normal to BC? Let us see. Let us see. If I draw a line like this, fine. If this is theta, this also must be equal to theta. So along your negative x-axis, it is FB cos theta. Along your negative y-axis, it is FB sin theta. So the vertically downward direction is FB sin theta. In a similar way, since this is theta, this also must be equal to what? Theta. Right? So FC can be split into FC cos theta in the same direction, but FC sin theta in the opposite direction. And you can see FB and FC are same. Why? Distance is same, charges is also same. FB and FC is also same. Right? You can write what is FB? FB is equal to what? K into Q divided by R square. So it is A means it is A square. Right? It is E square, right? What is Fc? Fc is what? K into Q square divided by A square. Both are same in magnitude, right? Same in magnitude but acting in opposite direction. Both will get right. The only force acting is F net value is it is 2F cos theta, because it is Fb cos theta plus Fc cos theta, both are acting in the same direction, so it can write as 2Fc cos theta. What is the direction of that? Direction is acting along negative x-axis. But I want a force along perpendicular to BC. BC either positive y-axis or negative y-axis will act out the force. What is the force acting normal to BC? The force acting normal to BC is 0. Right? So the answer must be C. Option C. It is normal to BC has played a role in this. Right? Next. Fifth one. Yes, guys, if you have any doubts, you can comment me on the chat box and respond to it. Or if you want any lesson to be taught, or even if you want any particular topic to be taught, you can put that so that I can start the same chapter on the day which we precise, right? So as of now I am dealing with electrostatics now. Before I have read meters force of motion, then work for energy we have dealt, then we have dealt with motion in straight line. Now I am dealing with electrostatics, right? So you will get a clear idea, or if you want me to solve any of the chapters, you can tell me that chapter is better, right? Now the electrostatic force between the two charges, of 10 microcoulomb and 20 microcoulomb at a certain distance F is to be halved, right? At a certain distance is to be halved. Let's say F is the force means it has to be halved, right? At a particular distance, right? This can be affected by option A, reducing both the charges by 50%. Reducing both the charges by 50%. If you reduce both the charges by 50%, see, let's go in common for this. Let us not be let us not fix up this for this particular question. Let us go in general for this. Okay? Not for 10 microcoulomb and 20 microcoulomb. At what distance the force will get halved, or for what value of charge the force will get halved at the moment. Right? Say, if you have two charges, Q1 and Q2, right? If you separate this by distance of r, then what is the force between them? F is equal to K into Q1 into Q2 divided by r. This is the value of r square, right? This is the value of force when you have two charges separated by a small distance of r. When it can be halved, let us see. So if I half both the charges by 50%, then what is that? That is, this will become Q1 by 2 and this will become Q2 divided by 2, right? So F dash would be equal to K into Q1 by 2 into Q1 by 2, which has to be divided by r square, right? So what it has become? F dash is equal to K by 4 into Q1 into Q2 divided by r square, right? And if you reduce both the charges by 50%, then force is going to reduce by 1 by 4 times of its initial force. Right? The force is going to reduce by 1 by 4 times of its initial force. Right? Now, this is not possible, right? Next. Reducing both the charges and the separation by 50%. Let us see now whether it is going to work out or not. Right? F dash is equal to K as it is. So obviously Q1 into Q2 divided by 4 is there, multiplied by, Q1 into Q2 divided by R by 2 whole square. That is R square divided by 4. 4 and 4 will get cancelled. So if you reduce, charges by half as well as distance by half, then the force will remain the same. Right? That is K into Q1 into Q2 divided by R square. There is no change. There is no change. Right? Then how to do it? Let us see. By doubling one of the charges and doubling the separation between them. By doubling one of the charges. Okay? If I double one of the charges and doubling the there is separation between them. Right? No, let us try this one also. By doubling one of the charges. If you double one of the charges, F dash will be equal to K into 2 times the Q1 divided by Q1 Q2 divided by doubling this one. What is this? Distance. Right? Doubling the distance means what? 2R whole square. Right? Again, the F dash is equal to 2 into K into Q1 into Q2 divided by 4R square. Right? So 2 1 it is 2 2. So F1 is equal to F divided by 2. Right? If you want to make half of the force, if you want to half the force, what you must do? You must double one of its charges and you must reduce its distance by, you must increase its distance by double. If you double its distance and double one of its charges, then you are going to half the force. So how I can make it as 1 by 4? You have seen what is that? Either you can reduce both the forces by half. Are you following it? Either, you have to reduce both the charges by half. If you reduce both the charges by half of its original value, then you are going to reduce the force by its 1 by 4 times the initial force. Right? So this is the general thing which is supposed to remember. Right? Next. Another option C must be your answer. Right? So what is the last one left? By doubling both the charges as well as the separation. This is not going to work out. 4 and 4 will get cancelled, right? So if you want to double it, if you want to reduce to half of it, what you must do? Double one of the charges by double one of the charges and double the distance. Right? Next. Two identical metal spheres with the charges 2q and minus q. Two identical metal spheres with the charges 2q and minus q are separated by a distance. Force between them is F. They are connected by a conducting wire and then removed. Right? The force between them now is how much? Right? Let us try to understand the question. A simple question to solve. The first one is two identical metal spheres. You have two metal spheres, but they are identical. Two spheres you have, they are identical. They have been separated by a distance of r, such that the one is having a charge of 2q and the other one is having a charge of minus q. Right? 2q and minus q. 2q and minus q. Right? Now, then what you are doing? The force between them is F. Right? Okay, that's fine. They are connected by a conducting wire and then removed. Right? They have been connected by a conducting wire and then they have been removed. Right? Now, you are supposed to find what is the force between them. Right? Now, Let us see and solve this problem. Initially, when they have been separated by a distance of r, what is the value of the force? F is equal to K into 2Q into Q divided by r square, right? Or you can write F is equal to K into 2Q square divided by r square, right? It is your first or initial force between the two charges, right? Now, I am connecting these two by means of wire, right? I am connecting these two by means of wire. What do the charges will do? What do the charges will do? The charges will always move from the point of higher potential to the point of lower potential, right? They always move from the point of higher potential to the point of lower potential, right? Can you follow? Now, if they start moving from the point of higher potential to the point of lower potential, then it means that the charges between 2Q and Q will get exchanged. If they get exchanged, then what happens? See, are they identical? Yes, they are identical. If the spheres are identical, then what will happen? The net charge of system, if the spheres are identical, remember, if the spheres are identical, the net charge of system will get distributed equally among both the spheres. The net charge of the system will get distributed equally among both the spheres, right? And if you have 2Q and minus Q here, what is the total charge of the system here? Total charge of the system becomes 2Q minus Q is how much? It is Q, right? Now Q will be shared equally among sphere 1 and sphere 2. And for sphere 1 the charge is Q by 2, and the sphere 2 the charge is also what? Q by 2. And the distance between them is R. Right? What's the point to be remembered in this kind of case? What is that? If the spheres are identical, then the net charge of the system is shared equally among both the spheres. That is, the total charge of the system is equal to the total charge of the system will get shared equally. That is, Q and Q will get divided to Q by 2 and Q by 2. Now you find F dash value. F dash is equal to K into what's the F charge? It is Q by 2 into Q by 2. Divided by, is there any change in the distance? No, there is no change in the distance, right? So it is R square. F dash is equal to C, K into Q square divided by R square multiplied by 1. Right? If you want to call this term as F1, you must multiply and divide by 2. Right? If you multiply and divide by 2, what happens? Let us see. Right? F dash is equal to, if you multiply and divide by 2, it becomes 2K into Q square divided by R square multiplied by 1 by 8. Right? So this is called as F now. If it is called as F dash is equal to F divided by H. Right? F dash is equal to F divided by H. Right? So the answer is F by H. Answer is F by H. I hope today's class is very clear and it is easy for you to understand. It makes your study still easier, I feel. Right? So as of today, I'm going to wind up now. I'm going to continue the same in my next class. That is, today is 19. I'm going to continue on 21st. Alternative days, every alternative days I'll be having the class. That is 19, 21st, 23rd, 25, 27, 29, like this. Right? Every alternative days I'll be having the class. Keep watching my channel. Keep liking the videos. Keep sharing it to your friends so that it can help anyone. Right? So thank you for joining today's class. Thank you. So let's stay tuned. Bye bye.